Hey, I'm Micah. Do you know how we use the base 10 system to write numbers greater than 9? In fact, we can use the 10 digits we already have to write any number greater than 9. For example, we can use the digits 1 and 0 to write the number 10. We can use the digits 5 and 1 to write the number 51. Also, we can use two 5s to write the number 55. But that creates a real problem. For example, if you have 55 sheep, which 5 is representing the 50 and which 5 is representing the extra 5? See the problem? That's why people invented the base 10 place value system. They agree that digit value will depend on where it is placed. For example, the symbol 5 by itself doesn't necessarily mean 5 ones, 50 or 500. People agree that a 5 in the ones place means 5. A 5 in the tens place means 50. A 5 in the hundreds place means 500. So let's go back to our 55 sheet. The 5 on the right is in the ones place, so it means 5 sheep. The 5 on the left is in the tens place, so it means 5 tens or 50 sheep. 50 sheep plus 5 sheep, that is our 55. In fact, as numbers get bigger, we need more and more place names to keep track of where each digit belongs. Here are the 7 basic place names you should know. But to understand these places, we need a starting point. The very first place is called the ones place. This is our starting point. That's why every new place is added to the left instead of the right. Move one place to the left and you have the tens place. Move left again and you have the hundreds place. After that comes the thousands, 10,000s, 100,000s, and millions places. And the place values just keep going to the left for as long as you keep writing bigger numbers. Alright. These days, most people never pay mind to learn math beyond the first 15 place values. Personally, I think you need to learn the basics you'll remember. But if you want to impress your mom, they're always there whenever you do. Every time you move one place to the left, the value becomes 10 times bigger. That's why it's called the base 10. It is based on powers of 10. That's why the same digit can have different values depending on where it is placed. For example, let's follow the digit 5 as it moves through this process. In the ones place, 5 means 5. In the tens place, 5 means 50. In the hundreds place, 5 means 500. In the thousand place, 5 means 5,000. The digit stay the same, the place value changes, and when the place value changes, the value changes too. Oh, did you notice the commas? They do a really good job for separating big numbers, so they are much easier to read. Starting from the right, we place a comma after every 3 digits, unless of course the number has 3 digits or fewer. But commas are not the only thing that help us understand numbers. Sometimes we need zeros to show empty places. For example, in the number 500, the 5 is in the hundreds place. The tens place and the ones place have nothing inside it, so we use zeros to hold those places. Alright then. Now let's see if you can figure this one out. Take a look at the number 4,582. At first, it just looked like 4 digits standing next to each other. But now we know a secret. A digit's value depends on where it is placed. Let's start with the digit 2. The digit 2 is all the way on the right, so what place is it in? That is right, the ones place. That means the 2 is where 2. Now let's move to the digit 8. The 8 is in the tens place. Remember, a digit in the tens place represents groups of 10. So 8 means 8 tens, and 8 10 is 80. Now let's look at the digit 5. The 5 is sitting in the hundreds place, so it means 500. That is 500. Finally, we have the digit 4. The 4 is in the thousands place, so it means 4,000. Let's put everything together. The 4 is really worth 4,000. The 5 is really worth 500. The 8 is really worth 80. And the 2 is really worth 2. But doesn't kind of feel like we stretched the number apart? Exactly. That is called a expanded 4. For example, 462 becomes 400 plus 60 plus 2. Because the 4 is in the hundreds place, and the 6 is in the tens place, and the 2 is in the ones place. Let's try another one. 8,392 becomes 8,000 plus 300 plus 90 plus 2. because each digit tells us how many of each group we have. So do you see how a base 10 number system works? Every place counts a different size group. Each group is 10 times bigger than the one before it. And even though the place values are invisible, they are always there, giving every digit its value. And that's the idea of place value. And that's it for today's lesson. Thanks for watching.